Hello class, we're at weekly update 9 and I wanted to share some work with you guys. Okay, in your Oaks I put in, where did I put this? Okay, so you're in module 5 and in the assignment section I put some work for the MATLAB simplex assignment. I liked the group of Avery, Brianna, Zach, and May, and then the group of Maddox, Kristen, and Ashley. So let's take a look at those. I think we'll start this one. And in fact, these guys are the winner of the competition. So you'll be check your inbox for a small little gift. So I really liked their discussion here. Why? So they clearly understood why I put these assumptions on the problem, because it makes it doable and much easier for y'all. And so read this paragraph here that they wrote, really nicely done. And then read these point by point discussion of how they were transforming the problem, giving some user feedback. Like if you didn't, you could enter it as a row or column and they would adjust. If the dimensions mismatch, they're going to exit and tell you that. So I think a couple of groups did that as well. They noticed that the Slack variables add appended identity matrix, again, makes it super easy. And output 2 things. I like their discussion here. They like to clean up the output, so it's actually just related to the original variables rather than the longer one with the slacks, which can be very confusing for a user too. So nice job. And then they timed it, which was cool. And they were on these small problems, theirs is much faster than the industrial strength learning prog, which is able to handle much bigger problems, but does a lot of setup and pre-processing and error checking that makes it much slower. So that was pretty cool. All right, so again, these guys get the A+ this week, and then they show their code. Super well documented, very clear. It's taken a while to load. Well, you'll see their code for, and again, the comments that I liked on that, it was just so well commented, but compact, only 130 some lines, very clean. And that's with all their well commented code that counted was in the line count. So let's go back and check the other group. Maddox, Kristen, and Ashley, really nice job. All groups got an A except for one struggled. And then it was the A+ for the winning group. What I liked on this one is, as a good coder often, and I'm sure all the groups did this, but like you're displaying things to the screen so you know where you are. And you can go remove that afterwards when you clean up your code, but like I'm at iteration 1, 2, 3, we did get an improving direction. They're printing it out. And it was clear that if you did this, there's somebody else in the background was helping, someone's coding, someone's helping, and like doing these by hand and make sure, did we get the right lambda? Did we get the right direction? And they got all the right answers for these. But when I get to, I want to show you their code. So that's their output showing that they got the right answers. Nice job. Also, Chloe and Olivia S, really nice job. Got all those to work on those 3 problems. So yeah, here's the code. Some really well commented code, which you'll notice in these guys. So there's a couple functions that they call. They created some sub functions within their function: adjacent non-basics, find the first direction. And so those are shown below. And this is just really good coding practice, right? I actually do my code more like the first group, Avery, Brianna, Zach, and May, where I just kind of dump it all in. But that's because I'm usually working on smaller things. But it's clear that Maddox, Kristen, or Ashley, someone's worked in a much, much larger code, probably doing this bigger problems. And then this is really how you keep things straight. So again, they're calling their functions, these built-in functions, and they're defined, adjacent non-basics. They're going to go find those with this little bit of code, this little snippet of a sub-function, find the lambdas, this little snippet. So, just a way of organizing. Not that there's right or wrong, but as things get bigger, notice that you probably want to do what this group did. Okay, let's go back and take a look at the next assignment. So the simplex polytope, really nice job on that. I put those answers in week 3. That was the week 3 assignment. I put everybody's in. I want you to take a look at everybody's for different reasons. So beautiful figures for this first group. But let's just talk too about their display here. I think there were a couple, and most groups actually did answer this one. This one is a half space and a half space, but there's nothing along here. So actually it's neither a plane or a half space. So I was being kind of sneaky there. Let's see, where else? Oh yeah, this one should have been the intersection of 8 half spaces, right? Because there's these 2 and then these 3, but there's another 3 for the greater than or equal to 0, the simple constraints x greater than x and y greater than 0, z greater than or equal to 0. Okay, really nice figures in here, polytopes. Throughout, they're showing their contour lines. I thought this was really masterful. Like how you were able to draw that is excellent job. Okay. And then they got the bonus right too. So let's quickly run down conditions on C. So C2 greater than 0, C3 is less than or 0. So nice job. All groups got A's or A pluses on this assignment. Let's look at Chloe and Olivia S. Also beautiful figures. Right, some nice shading ones. This might take a while. Their foam polytope is really nice. Here we go, drawn. We added the axes and makes it really clear, labeled the face each time. And then, oh yeah, so here they also use some computer software. Maybe that's CalPlot 3D, maybe it looks like. Showing the intersection of the optimal face, I think, on that one. And nice job on numbers 18 and 19. A lot of folks were able to say, hey, why not just start at the optimal solution and take 0 iterations? Most people got that. Number 19, here was several groups wrote this, like, hey, because any 2 extreme points are only 2 edges away, you can't do more than 2 iterations. And they didn't have all conditions here, but they said, here's one that works. So again, a little bit of bonus there, but not completely. Oh, I really wanted the conditions like the first group did. Okay, then let's look at the third one here is Ashley, Kristen, and Maddox. I like their visuals. Again, here's though where they showed, oh yeah, the contours of the objective plane slicing through. It was really neat visual of that. And then I also really loved their simplex, right? So to me, there's no doubt that every member of this team is going to do great on that big 30-point question on exam 2 on Monday of doing the simplex. You have to work your way through it. They did one of this size, no problem. Show all the steps is very clear. And they did that for the next one. And then the other reason I wanted to show theirs is their example for their answer for number 19. I think this was the only group that noticed, hey, there's actually degeneracy in the problem. Now, how did they notice that? Well, because they were actually writing out the simplex in this manner and made it very clear to see that this is, in fact, this is a highly degenerate problem. It's one that I worked on for my research. And that degeneracy has some pros and cons, right? So we talked about that in the videos and in class. So nice job on this one. So A+ for this group. And let's do the last one. Is the group of Jenna, Kevin, Naomi, and Olivia L. This one, I wanted to point out, they noticed some multiple optimal solutions, and I think they might have been the only group. So really nice polytopes as usual. Let's see, which one is it? There's one where they were like, hey, the answer is this or this. Most people didn't quite see that. Maybe it was the orientation of the plane that they were doing it in the physical one. And then their answer for the bonus was really good as well. So they got the same as group 1, C2 positive, C1, C3 negative. And I forget which word. There was a group, and maybe this was Kristen, Maddox, and Ashley also said, well, if it was a minimization, here's the other condition. So they extended that a step further, A+ for that group. And in fact, everyone got A's and a couple groups got A+. So excellent job on these homeworks. Okay, so last thing, our exam is this Monday, exam number 2, Monday, November 8th. Check out last week's. So this is weekly update 9. Check out last week's weekly update 8. Has a lot more details about exam 2, like the number of questions, the percentage of points. And last thing, check out that update for information about next semester's class 452, 552, And there's also 480. I'd love to see you guys in that class. I think we'll have a lot of fun. We'll covering, or I asked Maddox about that class. He's already taken. But we are covering, we'll do a lot of projects, smaller mini projects on topics like markup chains, information retrieval, text mining, the vector space model, PageRank and Google, how the search engines work. And just shoot me an email if you got any questions on those. Otherwise, I'll see you guys Monday. We have to be during our class time with our cameras on. All right, have a good weekend.